So good afternoon and a very warm welcome to customers, partners, friends from the media, analysts as well, and a special welcome to our chairman, Mr. Parekh, and members of our board of directors who are also here today. This is the first ever Siemens Innovation Day that has been held here in the country. And we are delighted that it could happen, as Ramya mentioned. In 2016, it started in Munich and then went on to the US, on to China, the UAE, and is today here in Siemens in India. Now, primarily what we are trying to showcase over here and what has been showcased in the past has been really how digital solutions, innovative digital solutions, can make a real difference to creating value for customers and indeed for societies as a whole. Now, there's a lot of talk that has gone around digitalization and digital solutions, but really there are very few cases where we are able to showcase what precisely has been the impact of this. And what we hope to do in the next couple of hours is really exhibit to you through the discussions that we will have, through the exhibits that we will have, and through the lab sessions that you will go through, what really has been the impact of digitalization that Siemens has already started. Now, to talk more about this, I am delighted to welcome Dr. Roland Busch, member of the Managing Board of Siemens AG and Chief Technology Officer of Siemens AG. Dr. Busch is really a global expert on digitalization and has been driving the digitalization initiative within Siemens in India, within Siemens globally, also in India. He is also responsible for the mobility business and the building technology businesses, as also for the regions of the Middle East and the Commonwealth of Independent States. So we are delighted he could be here. He is a frequent traveler to India. Until recently was a member of the board of Siemens Limited in India, the flagship company. So he knows India very well, and we are delighted that he could come here to really host and lead this Innovation Day today. So thank you very much, Roland, for taking the time to come. Now, over the next couple of hours, I hope you will have the opportunity to really visit some of our exhibits, because what we are trying to show over here and demonstrate is how digitalization really makes sense in the Indian context. And we will be showcasing what the future of energy could look like here in the country. We will showcase what cybersecurity will look like, how smart infrastructure in cities could look like. We will showcase predictive maintenance, what kind of an impact that has, and of course, smart manufacturing. Now, these are all huge subjects, particularly in the Indian context, and I don't need to tell all of you the kind of impact that it is going to have and is indeed happening in our country already. So I'm delighted that you have been able to come, but first we need to start with our keynote address, and it gives me a great pleasure to invite Roland Busch to come up and really talk about how digitalization, the potential of it, can really be unlocked in the global arena as also here in India. Roland, over to you. Thank you.
Well, good afternoon and a warm welcome to customers, partners, friends, to our esteemed board. Well, I'm going to talk about innovation, and of course I will put a particular emphasis on digitalization and try to explain what it means, what our technology looks like, and how can digitalization bring benefits to our business and to your businesses too, which is not very well understood. And it's difficult within half an hour to bring that message across. How does our technology stack look like? How do we drive really digitalization at the front end? And I try to explain it also a little bit in technology terms, what we are doing here. But let me start with giving you an overview on, that would be helpful if that screen works. let me give you an overview on what Siemens does in total in terms of innovation. So we are, last year, so fiscal year 17, we spent 5.2 billion euros in R&D. Ever since Siemens was founded, we increased in absolute terms and in relative terms, and we are heading for 5.6 billion in 2018. This is another increase of 9%. Compared to 2014, we increased by 40%. This is also a fact of digitalization because we are blending more and more software business into our business. We invested more than 10 billion over the last years, and software business comes with a higher share of R&D. Hence, we have a mix effect too, but we're also constantly investing. In that point, our CFO then always asks, I mean, this is input, but I would be more interested in the output of your innovations. And hence, I think I was thinking about running you through my personal highlights about what innovation did and what kind of outputs we generated. And you saw that already 25,400 engineers of ours are sitting already on software technologies. The total amount is 50,500, so it's more than half of them are already working on software technologies. Well, what are my highlights? Artelica, this is a blood diagnostics platform. This platform outperforms any other platform in the market with having a sample speed which is 10 times faster than any platform in the market using magnetic levitation sample holders. The next one is our newest innovation on trains. This is a commuter train using lightweight materials, highly efficient propulsion systems. We're using 20% less energy, but it's also flexible in terms of size. We can size it to the customer's needs, and a customer can, using virtual reality, really configure it according to their individual needs. The next one, this is our world record in HVDC. This is a transformer, HVDC transformer, 1,100 kilovolts, and when it ends up in this case in China, it will transport 1.5 gigawatt over more than 1,000 kilometers, which is a world record. And you see the people, how small they are there. Next one is on printing technologies. What you see here is the front blades of a gas turbine exposed to temperatures where the material is melting. It doesn't melt because it has cooling inside, and these cooling channels inside, we manufacture them using 3D printing technologies, give a completely different way of manufacturing them. They come out of the printing machine, go directly into the turbine, and run there, which nobody has done before. And the last one is, for me, also a very exciting one. On the left side, you see a part engineered by engineers. That one on the right side is engineered by a computer. A computer designed this product which can hold the same forces. It's much lighter, but you cannot forge it. You cannot manufacture it the same way how I did in the past. This can be only printed. So what we do is not only changing the way how we're using technology in terms of printing, but we also change the way how we are engineering. And this is another example which I like. So, and there's much, much more. So we do see an outcome, and we're very proud of that. Next thing what we did is we were focusing our investment in R&D in so-called company core technologies. And you see them coming up on the screen, 14 of them. We came to that in analyzing our markets, our today's markets, our future markets, not from a technology perspective, but from a market perspective. And we deducted out of that 14 technologies where Siemens has to stay in the lead. We are investing 500 million in advanced research and first kind of applications in these 14 technology fields. Most of them, you recognize, most of them have something to do with any kind of digital technologies. Some are pure digital, AI, for example, software, digital twin, materials less though, but even materials are affected because they are going very much into any kind of 3D printing or additive manufacturing technologies. The second thing you might, and you have blockchains there, which we believe is something which happens as we speak, which goes into the business. There are two of them which you might stumble, where you say, why are they showing up in the field of contemporary core technologies, and this would be decentralized energy systems and connected mobility. Because people are saying connected mobility, is that technology? Well, the key thing about digitalization is that, and this is one of the answers to the question, why does it happen now? Why doesn't it happen in that speed? Three elements coming together. Technology, material, the cost for photovoltaics going down, and all that stuff, storage. Second one is digital technologies. Storage, processing power costs nearly nothing anymore. Connecting devices costs you nothing anymore. 5G coming in, so it's a huge amount of processing power coming up where our algorithms are working and using data. The amount of data, hence, is increasing. But the third element, and this brings me back to DES, decentralized energy systems and connected mobility, the third element is digitalization is going to change the business models. Think about Uber, Airbnb. This changes the business model substantially in short time. And this is where we believe innovation happens too. It's not only technology, core technologies like materials. Innovation comes also in the way how you're using your capital in order to create value for customers. Sometimes we don't sell trains anymore. We do sell uptime or turbines. We sell maybe electrons or power or energy, combining heat and cool. So this is the element, and hence it's not only technologies, it's also business model which are changing. We are investing 500 million, as I said, in corporate technology, but also in our businesses, and driving this to the market. In calling for these corporate core technologies, we also covering the whole 9 yards of the innovation cycle. There's one leader for each technology field, covering also the university collaborations, because you have to have a strong ecosystem too. And university collaboration makes a big difference. But now we have somebody who is coordinating that for the whole company, rather than having individual agreements. We do that in application. When we go even down to the first applications, this is another lesson learned, that in the digitalized space, where speed is so fast, the difference between what is advanced development and what is application is somehow blurred. I mean, it really moves very quickly into the market. So our AI experts, for example, they are really sitting at the forefront of developing or using their technologies in really real-time applications for customers creating benefit. So therefore, it's a big blend. And next, and the last thing what I want to mention is Next 47, which is our venture capital investment arm. We are going to spend 5 billion over 5 years, and we're looking very deep into this, what's happening in the startup scene, in all these technology fields. There's quite a good match where our money flows and venture capital money flows, and we are looking into that space too. Well, digital age is about speed and scale. You know that. Why? Once you have a software developed and you sell it again and again, it's pure margin. I mean, if it scales, you just get more of the same. Reproducing it doesn't cost you anything. And the second one is the winner takes it all. If you have a platform, you scale it up as fast as possible. The more leverage you have, the bigger your ecosystem is. So therefore, this is something of essence, and we hope can show you that we played that quite right when I come also to our MindSphere and MindSphere application centers. So, how does a Siemens business look like? And I come now to the part of digitalization. I tell you what's happening. Still, it's a small part of our business. If you read the chart from the bottom, you see we have 43 billion of enhanced or enhanced electrification business, which is mechanical, electromechanical, sensors, actuators business. Above that comes 19 billion of automation business. We are the largest automation company in the world. We automate everything. I mean, from healthcare scanners, trains, buildings, manufacturing sites, you name it. Then you have 17 billion classical service. Classical services, when we send our service engineers to service a part, when our textbook tells us to service a part. And this differentiates from digital service. This is where we go when a turbine tells us, I need a repair, or I need a repair in a couple of hours. Or when a door speaks of a train, says, I will fail in 10 days from now, please order the spare parts because this is why. This is digital service, 1.2 billion, 4 billion pure software business, software license business and the like. So a total 5.2, which is a small part yet of our revenue, but it grows fast. It grew by 20% nominal, 11% if you exclude our acquisition of Mentor Graphics, in a market which grows by 8. So high growth, yet on a smaller scale, but we see a tremendous impact and a tremendous growth rate there. And one last thing, don't see that decoupled. If you talk about digitalization in the IoT, in the Industry 4.0 space, it is really a digitalization which connects really these dots from electrification over automation to digitalization. You have to bring that together, otherwise it will not work. What does make Siemens different from our competitors? Why do we believe we can do that a little bit better than others? These are the 5 elements. First and foremost, and this is very often misunderstood, digitalization, everybody talks about that's another IT application. Well, it is and it's not, because you do need domain know-how. It is important to understand how you build a train, how you build a turbine or a building, how you manage a building, how you run a building, in order to get all the benefits from digitalization. Secondly, it's the installed base. Why that? This is where the data are generated. All the parts which are sitting in the fleet, 40 million automation devices in Siemens' case, all these devices are generating data, and we are capturing data. We are capturing data from 50,000 buildings on a daily basis as we speak. So this is an asset which we can tap on. Then we have a very powerful ecosystem, which we are expanding. I will talk about that in a minute, which is very important. We have an unmatched portfolio. I was talking about this, and we'll show you a little bit more details, including MindSphere, our platform for our operating system, as we call it. And last but not least, our customer access. We have a very, very strong interaction with our customers, which is one of the strong footholds which we can play in order to really come up with solutions. We understand our customers' pain points maybe a little bit better. Talking about our platform and our software offerings. Over the last 10 years, we invested more than 10 billion in our software suite. And the end result of this is we have a very strong CAD, CAX portfolio. We can build a digital twin of maybe every part. But a digital twin very often is misunderstood that if you have a 3D picture of what you do, that's good enough. It's not. It's also about simulating heat dissipation, simulating mechanical stress, simulating fluids, air fluids, whatever kind of, if you expose your part to any kind of fluid, or simulating the electric flow in a part, or even simulating the software running on your digital twin. We can basically simulate almost everything. Latest acquisition TAS, for example, it simulates crash of cars. It can even simulate an autonomous car, how it drives. So that's one of the big differences which we have. Siemens is one of the 10 largest software companies in the world. The next one is about our ecosystem. When we go out and we deploy our technology to our customer, it's important that our customers understands that we are coming with a huge ecosystem behind us. It's an ecosystem on technologies. You see a couple of companies there, amongst them, of course, SAP or Atos, Amazon. These technology partners or integration technology partners are providing, for example, cloud services and data center for us. We are adapting our platform and vice versa. These are integrators. Once we have a solution for a customer, somebody has to stitch it together, bring it to life. We need integration partners on a global scale. We have many of them. And then, of course, application developers. These are the companies which help us bringing any kind of applications to the market. We will talk about applications in a minute, which is the essence, because any platform, any operating system doesn't do the trick if you do not have the right applications on top. So the ecosystem is one of the essential elements. This is only part of it, and it increases as we speak. And you see at the top, we do consider our customers being part of our ecosystems too. So coming to the digitalization, what does it really do? And this is explained in the way how we are describing the basically a digital twin, and you can do that in manufacturing or infrastructure. The basic idea is, let me take the first line on manufacturing. You start with a digital twin. That means the product you want to manufacture, you build it on your computer completely, as I said before. You build it, you simulate heat dissipation, how it behaves, make it really work on your computer. Once you have that, you do the same for your manufacturing line. So you build a digital twin on the computer of your manufacturing line. You simulate also the people standing there, how they assemble a part, your robots, whatever you have, the lines, and you take the digital twin and put it into the digital manufacturing. Currently, you didn't touch any hardware. You just simulate. Once you do that, you bring it to real life. You build it. Could be a greenfield, could be brownfield approach. And once we have it built, obviously you run it, and then we have a third twin, which we call the performance twin, which is we are permanently looking and upgrading our twins and looking at how does it work. Gathering data, understanding what happens, and what is our predictive flow, and how is our real flow, and where's the difference to optimize it. If you have a product in the field which is not doing good, where's a part is wrong, and you have to change it, think about what happens in the past, then you have to go back, you change your drawings, you implement it, you make a test, you see how it goes, you bring it to the manufacturing line, you see what kind of changes you have to make. Now, you can do that in a digital world, adapt it, and bring it in one shot back to manufacturing site. What I'm saying here is can shorten your cycle time of development substantially. We have examples where we shorten cycle time by more than 30 or 40%. So this is the basic idea behind it. And now you wonder what is MindSphere about and how does that look like? And this I'm going to at least try to explain it to you in 5 or 10 minutes, which is difficult because it's rather complex. So where does it start? It's very obvious. It starts where the data are generated. This is where connectivity is the name of the game. And what you see here is a sample of what Siemens kind of verticals we are covering, what different kind of applications we are covering. Why is it so important to highlight? Because connectivity is maybe the first, but maybe one of the most complex elements. We are connecting, on the right side, this is a symbol for healthcare. We are connecting a corporate CT or MR, sending you a terabyte of data in 20 minutes. But we are also connecting on the left side, if you go for a turbine, we are connecting a turbine where 1,500 sensors are sending a couple of bytes quite often. We are connecting smart meters, 50 million of them, sending every 5 minutes a couple of bytes. And then we connect with different languages. A train has a different language, they call it protocol, than a CT scanner, than a semantic device in manufacturing, has a different protocol than a pump which sits on your oil and gas field. So we have to speak different languages. Next thing is, if a customer says, okay, now you tell me how to connect, next thing is how to make it cyber secure. How do we avoid that if I connect something, somebody hacks in from the rear and goes into my system? The next one is, some customers say, I do want only to read, just getting the data out. Others say, I want to manage, I want to write. So you have unidirectional or bidirectional communication. In the signaling industry, they say, I don't allow you to write. I want to have a very secure, just one-way communication. So we developed a communication diode, which physically allows you transferring data only in one direction. And then comes maybe the most complex element. You would not worry what happens to your connectivity if you have a smartphone in your pocket in 2 or 3 years from now, because it's anyhow a new one. These devices are sitting there for 10 years, maybe 20 years, and you want to update them. A latest cybersecurity update, software patch, in the field, all at once, out of the cloud. So now you got a glimpse of what connectivity means and how complex it can get. Once you have that, and this comes with a MindSphere. MindSphere is connecting your devices. This is our cloud-based open operating system. Once you have the data, you have to store them somewhere. This is where MindSphere comes in and brings you an access to any kind of cloud services which you have in the market. We started off with SAP. Amazon is now working on our platform with the version 3.0. Azure, so the Microsoft cloud services are coming in April or May. Azure on Stack, which gives you an on-premise solution too. So then you have access to processing power and storage and all the cloud services. We do not redevelop cloud services which are available. We take this as part of our ecosystem, allow our customers to use their cloud services. But if some customers say, I want to use my own servers, we can cater for this too. MindSphere does also give a timestamp your data. If you're collecting data from different angles, your analysts will tell you, I need a very clear timestamp on each data so I can correlate them. So we give them a timestamp. We give access control. We monitor the amount of data which are running through. We do have any kind of artificial intelligence algorithms sitting in our operating system. So this is where we have a very powerful platform which we offer to our customers too. And then, with that, you would not do any trick. You would not have any benefit. Then comes basically the application layer. Is it either the software or the digital services and the applications on top? This is where the rubber hits the road, where you really create the benefit. And you see on top, I just explained to you the upper right side, Flex LTP is our industrial application platform which makes predictive maintenance for any kind of rotating equipment. The Navigator is our application platform which enables you to manage buildings, one building, a fleet of buildings run in a much more efficient way. Railigent, this is a platform which works on trains and gives you any kind of information on trains and benefits. DCGO CC is another building technology platform. And I give you now a couple of examples before I come back to this one. Within 1 year, we had 25% more assets connected. Now we are having 1 million assets connected, which we're gathering in our MindSphere. Within 1 year, we doubled the number of our customers, plus 2,900. And within 1 year, we increased the amount of applications 4 times. And applications are really use cases customers would pay for because they see a clear benefit. And I come to these use cases now. I give you a couple of examples. I can go on and on, but I just picked some. It's in Jacksonville, USA, where a customer, it's about a utility customer, is 65,000 meters. He wants us to collect the data and create more value in terms of having an automated workflow, but also offering prepaid kind of offerings to customers. And at the same time, he wants to optimize his operations. And in doing that, in automating and guessing all the data of the grid, he could really reduce their maintenance cost by 1.6 million, payback time 1.5 years. Next one is longer service intervals. If you look into our turbines, we, as I said, we don't go and repair when the textbook tells us. We go there and repair when we really need to repair. We can deduct it from the data coming from the turbine. So this gives you 30% longer maintenance intervals, 16% lower cost. These are hard facts which we have proven in customers' use cases. The Navigator, which is basically, as I said, optimizing buildings as you manage it. We have them connected to 20 building offices at Capital One in the United States, and they had 10% energy savings. And again, this is not exchanging devices. It's running the system just smarter. It's incremental investment which brings you benefit. And we are constantly monitoring data. We are about to run out to much, much more buildings of theirs. And this is another one which I love very much, 70 Vectrons. These are locomotives running. And these locomotives, they have now more than 30% fewer delays because we can predict how a locomotive behaves. Another example also from that space using Railigent is monitoring doors. If you talk about to a metro operator, the biggest headache of any metro operator is the door. You won't believe it, no? You shoot people to the moon, but the doors of a train is still an issue. And these doors if they don't work, obviously you have to stop the train. Our guys, they're monitoring the data from the train, but not only our train, but also those of our competitors. And now they can tell you, they started off having a predictive view for 2 days, Meanwhile, they can predict for 10 days which door on a train is going to fail and why. So that gives the opportunity for an operator to pull the train aside, order the spare part up front, replace it, and bring it back to operation. We are really heading for 100% availability. Gearbox, by the way, is the next one we are working on. And for some lines, high-speed lines in Russia and Spain, we are working our high-speed trains with availability of 99.9 whatever percent, 7%. Another building example. Question now is, how do we do that? How do we create these applications with a higher speed, more impact, to the point? And here is our concept, what we call MindSphere application centers. What does it do? It brings domain know-how together with a strong portfolio of ours, together with experts on analytics. We talk about really AI experts, and we bring a certain integration competence together at one place, focusing on one vertical. So it does not do the trick if you bring these people together and in the morning they work on any kind of automotive applications for automotive car manufacturers, and in the afternoon they work on buildings, and the next day on healthcare. These are dedicated MindSphere application centers for dedicated verticals, because the domain know-how is important. They have to think from the morning to night, think about how can I work, how can I get these doors, which are sometimes not opening again, how can I solve that problem? And again, gathering data, as many data as you can get, and co-location and co-creation with customers is of essence. The customer knows best where his pain points are sitting, what he wants to solve, and how can we improve his life. So this concept is generating this industrial applications, digital services, and the like. We started off in putting these application centers in place 1.5 years ago, and as I said, we ramped it up quickly, speed and scale. We have now on 50 different locations, 20 different verticals which we are covering, and we have 900 highly expertised guys on AI experts and domain know-how people sitting in these places working on solutions for all these verticals which you see here. Is it chemical, pharmaceutical? Is it electronics? Is it distributed energy systems, buildings, cities, food and beverage? Each of them focusing on special verticals, and they are sitting all over the place, and most of them next to customers. One of the last ones I was opening was in Perth. Perth is for metals and mining, sitting next to BHP Pillington. I mean, these guys know really what mining is about. And we have 4 of them, Gurgaon counts 2, 4 of them in India. This is a start. We're very proud about it. Focusing in Gurgaon on steam turbines and process industries, in Noida on energy ERP, smart grids, and in Pune on power generation services. Since we started, we have with 150 customers engaging, and we have 100 projects, digital projects running already in discussion in order to create use cases into that. One last word on these application centers. You wonder now, how do we make use out of these applications? And that's what you call App Store in the consumer world. We call Reference Plus. This is our app store for all these applications generated in Gurgaon, for example, to share with customers in the United States, in Germany, and to take advantage out of it and redeploy them. So this is one way how we can multiply, and likewise. So you have a huge reference, and each of these application centers are creating use cases as we go along, scaling up our applications, and we multiply it to the world. So this is now, I mean, I really have to put this in, because you saw, and we talk about smart cities all the time in India, and this brings me, and you also saw that we have a MindSphere application center for cities. And this brings me back to one of the experiences I had when I was visiting, and by the way, this one sits in Hong Kong, when I was visiting Hong Kong, and in the morning I met the utility there. And we started talking about, start on the left, in the morning we talked about power generation, the grid, and the prosumer, the consumer who is producing energy too. And obviously the utility comes from power generation and the grid. And we said, well, what you can do is you can use our MindSphere applications, Flex LTP, Energy IP, I talked about it, our solutions for decentralized energy solutions, and we bring you solutions to optimize your fleet maintenance, to optimize your grid. And then you said, well, but I want to get closer to my customers. My building customers said, well, we have a DES, Decentralized Energy System solution, so you can talk to your customers too, and you can put our applications in place. In the afternoon, I met the head of the metro. And the guy was telling me, well, I have rolling stock, I have signaling, I have my stations. By the way, the metro in Hong Kong, they own the stations. And I do have end customers too. And we said, well, if you take MindSphere as an operating system, with Railigent, we can take care about predictive maintenance for your trains. We can also tell you how you maintain your infrastructure and your systems. But on the stations, we can help you in managing and optimizing your energy efficiency, because a station is basically a commercial building. And by the way, we are also in the chance, we have a chance for you to optimize your trips end-to-end, because we have a platform using Hakon, which is our software, for make end-to-end trips, and putting any kind of benefits on top. And then a day later, I met people from the government, and they were talking about how can they improve their airports, their strategic infrastructure, including buildings, and I could offer to them. And then I said, hold on a second, if I can get maybe each of them at least adapting to one of these applications, I could solve the sector coupling problem of each city, because energy doesn't talk to mobility, doesn't talk to the buildings. What you could do is you could run, using third-party applications, you can run and connect the dots and put a basic operating system of a city where you have the data and you can exchange the data and you can take benefits. Why is it so important? Think about electric cars. This is where the electric sector meets the mobility sector. It's a kind of a combination. You cannot draw a line in between anymore. And the power of combining these sectors and make a sector coupling is so important. Each of these columns is a use case on its own. So it makes sense. It pays back on its own. But if you have that connected, the dots, and then you have also third-party applications running on it, because this is what I forgot to tell you, northbound, MindSphere is open for any kind of third party developing their own application using the data which you are gathering and run it on this one. Well, this was a quick run over the strategy of Siemens, of our technology stack, what we are offering to our customers. I hope to share with you what we can do in terms of applications and bring use cases to customers. There's many, many more which we can share. A lot of them are developed also in India. MindSphere is also developed, quite a portion of it from Indian software developers in Bangalore. What I wanted to share with you is we have a clear way how to allocate our capital. Remember, 5.2 billion R&D spendings, creating 5.2 billion of software and digital enhanced revenues. We leverage our domain know-how, our expertise, our customer access, and bring that very close to our customer. We take our customers as our partners in our ecosystem, co-generating value. And this is one of the biggest advantages. And we do that with speed and scale, in scaling up our MindSphere application centers in all countries, locally at our customers, and in India too. Thank you very much.
Thank you, Dr. Bush, for your incredible insights on digital technologies and the shape of things to come. With a comprehensive knowledge of market